In the heart of Siberia, where the temperature plummets to -72 degrees Celsius, a breath exhaled crystallizes before it reaches arm's length. Blood freezes in veins within minutes of exposure. Metal shatters like glass. Car tires flatten against the ground as if made of concrete. Yet in this kingdom of ice, indigenous Yakut people have thrived for centuries in homes that maintain life-sustaining warmth without a flicker of flame or pulse of electricity. This isn't just survival. It's mastery over one of Earth's most unforgiving environments, using nothing but inherited wisdom and materials pulled from the very landscape that threatens to kill them. If this exploration of extreme human adaptation interests you, subscribe now. Let's continue our journey into one of humanity's most remarkable feats of environmental engineering. What you likely imagine when thinking about staying warm in Arctic conditions is what modern technology has taught us. More energy, more fuel, more insulation, more heat. Yet the Yakut approach inverts this entirely. Their solution isn't about generating enormous amounts of heat to combat the cold. It's about preserving the minimal heat that already exists and understanding the subtle physics of thermal balance that modern construction often ignores. The Yakut people, also known as the Sakha, inhabit the Republic of Sakha in northeastern Russia, a region spanning over 3 million square kilometers where winter temperatures regularly reach -60 degrees Celsius and can plunge even lower. In this environment, the margin between life and death is measured in minutes, not hours. Yet their traditional dwellings, called balagans, maintain temperatures that allow human habitation through months of darkness and cold that would render modern homes uninhabitable within days if power failed. The ingenuity begins not with what the Yakuts add to their environment, but with what they understand about it. Their approach to home construction starts with positioning. Unlike modern developments that prioritize views or property lines, traditional Yakut settlements are strategically placed in natural depressions or on south-facing slopes partially sheltered by forests. These locations are selected to minimize wind exposure while maximizing the scant warmth from the winter sun and protection from the biting northern winds. The foundation of a balagan reveals the first counterintuitive principle in Yakut construction. Rather than fighting against the permafrost as modern construction does with expensive heated foundations, Yakuts work with it. The permafrost becomes an ally, not an enemy. Traditional dwellings are built directly on the frozen ground, using it as a stable platform that actually helps insulate the structure from below. This foundation layer typically begins with a framework of larch logs laid horizontally on the permafrost. Larch is specifically chosen for its exceptional resistance to decay, even in direct contact with soil, containing natural preservative compounds that allow it to last for generations without treatment. The logs are notched and fitted without nails, allowing for slight movement during temperature fluctuations without compromising structural integrity. Above this foundation emerges the core insight of Yakut thermal management, the multi-layered envelope. The walls of a traditional balagan consist not of a single thick barrier, but of multiple distinct layers with specific thermal properties. The inner wall is typically constructed of vertical larch logs, split and smooth with traditional tools. These are tightly fitted but not sealed, allowing for crucial minimal air circulation that prevents moisture buildup. Between the inner logs and the outer layer lies the critical insulating chamber. Here, Yakuts pack materials that modern science has only recently recognized as superior insulators, a mixture of dried moss, grass, and animal hair. The moss species commonly used, sphagnum, possesses remarkable properties. Its cellular structure contains tiny pockets that trap air, creating millions of miniature insulation chambers. Additionally, this moss has natural antimicrobial properties that prevent rot and mold growth even in the humid interior conditions that can develop when humans occupy an enclosed space. The outer wall is another layer of logs or sometimes birch bark sheets, creating a protective shell. The space between layers isn't uniform but is engineered to be thicker on the northern exposure and thinner on the southern side, reflecting an intuitive understanding of directional heat loss that predates thermal imaging by centuries. Perhaps most ingenious is the roof construction. Heat rises, making standard roofs the greatest point of thermal loss in most structures. The Yakut roof is a marvel of engineering, typically cone-shaped or sloped to shed snow, but with critical thermal features built in. Multiple layers of birch bark, naturally water-resistant and surprisingly durable, are overlapped like shingles. Above this, dried grass and moss create another insulating layer, followed by a final covering of earth and sod that freezes solid in winter, forming an almost impenetrable thermal cap. A small smoke hole at the center serves dual purposes. It provides minimal ventilation and allows for smoke escape when cooking is necessary. During the coldest periods, even this opening is partially covered, leaving just enough space for essential air exchange without significant heat loss. The entrance to a traditional balagan reveals another sophisticated thermal principle. Rather than a single door that creates a direct path for heat escape, Yakut dwellings feature a cold trap, a narrow, low entrance corridor that forces anyone entering to bend down, minimizing the aperture through which warm air can escape. This entrance tunnel often turns at a sharp angle, preventing wind from blowing directly into the living space when the door is opened. Inside the structure, the floor design incorporates principles of passive thermal regulation. The earthen floor is slightly excavated below ground level, creating a subtle heat sink. Around the perimeter, sleeping platforms are elevated above floor level, taking advantage of the natural stratification of air. Warmer air rises, keeping the sleeping areas several degrees warmer than the floor. What makes these structures truly remarkable is their performance without active heating. The only heat source comes from the minimal metabolic output of the inhabitants themselves, body heat from humans and sometimes animals, plus the occasional cooking fire. This minuscule input would dissipate instantly in a modern home. Yet within a balagan, it accumulates and is preserved, creating a microclimate that can maintain temperatures 40 to 50 degrees higher than the exterior environment. The Yakut understanding of thermal dynamics extends beyond the structure itself to include clothing and daily habits. Their garments, made from reindeer hide and fur, function as mobile extensions of their shelter philosophy, multi-layered systems that trap and preserve body heat rather than generating it. Similarly, daily activities follow patterns that conserve metabolic energy and minimize exposure to extreme conditions. What modern engineers are only now beginning to appreciate is how the Yakut approach embodies the principle of thermal efficiency rather than thermal excess. Western construction has long relied on the assumption that unlimited energy would be available to heat spaces, leading to designs that require constant energy input to remain habitable. The Yakut balagan stands as a counterpoint, a structure that achieves thermal autonomy through design intelligence rather than energy consumption. This brings us to a profound realization about the nature of true sustainability. The Yakut dwelling isn't simply conserving resources or minimizing impact. It's achieving a state of dynamic equilibrium with its environment. It represents not just adaptation to extreme conditions but integration with them, turning environmental challenges into structural advantages. As climate instability increases and energy security becomes more uncertain, the principles embedded in these traditional structures take on new relevance. Modern buildings typically achieve R values, measures of thermal resistance, through complex manufactured materials that require substantial energy to produce and eventually create disposal problems. The Yakut system achieves comparable or superior thermal performance using entirely biodegradable, locally sourced materials that function in a continuous cycle with their ecosystem. The insulation materials, moss, grass, and animal hair, are renewable annual harvests that require no processing beyond drying. The structural elements come from slow-growing northern forests where timber harvesting, when done in the traditional selective manner, actually promotes forest health. Even more remarkably, at the end of its life cycle, a balagan decomposes back into the landscape without a trace of environmental harm, a concept modern architecture is still struggling to approach. What's particularly notable is how Yakut construction harmonizes with the rhythm of seasons. The gathering and preparation of building materials follows the natural calendar: moss harvested in summer, timber collected and processed in spring after the sap has risen but before full leaf out. This timing isn't merely practical but reflects a deeper understanding of how material properties change throughout the year. Bark stripped at the right moment in spring peels in perfect sheets. Wood cut in winter has different structural properties than summer-cut timber. The temporal dimension of Yakut building knowledge represents an aspect of sustainability rarely considered in contemporary practice: the alignment of human activity with natural cycles. This isn't just a romantic notion but a practical optimization that modern construction has abandoned in favor of year-round building enabled by global supply chains and artificial environments. Perhaps most relevant to contemporary challenges is the resilience inherent in the Yakut approach. Their dwellings require no supply chains, no specialized parts, no imported expertise. Every element can be replaced or repaired using locally available materials and generationally transmitted knowledge. In an era of increasing supply chain vulnerability and infrastructure fragility, this self-reliance represents a form of security modern systems struggle to provide. The thermal principles of the Balagan also provide insights into bioregional design. The idea that buildings should be specifically adapted to their particular climate rather than imposing a standardized approach across different conditions. The same techniques that work in Yakut territory would fail in a humid tropical environment, but the underlying principle, working with natural conditions rather than against them, translates across contexts. As we face the dual challenges of climate adaptation and energy constraint, the Yakut example offers not a blueprint to copy but a methodology to adopt, understanding the specific conditions of place and designing in harmony with them rather than imposing solutions that require constant energy input to maintain artificial conditions. The social dimensions of Yakut construction also merit attention. Unlike modern building, which typically requires specialized labor and tools, traditional Balagan construction involves the entire community and relies on simple tools that can be locally made and maintained. This distributed expertise creates resilience. If one knowledge holder is lost, the essential information persists within the community memory. The construction process itself strengthens social bonds and transmits knowledge to younger generations, creating cultural continuity alongside physical shelter. This integration of shelter with social structure points to something often overlooked in discussions of sustainable building: that true sustainability isn't merely technical but social. A technically perfect building that requires specialized knowledge unavailable to its inhabitants creates dependency rather than resilience. The Yakut approach ensured that those dwelling within a structure understood its principles and maintenance, creating an unbroken chain of building literacy that modern specialization has largely severed. As the Arctic experiences warming at rates far exceeding global averages, the Yakut people face new challenges. Permafrost that provided stable foundations is now falling in many regions, compromising traditional building approaches. Rivers that were predictable for centuries now flood irregularly. Forests face new insect threats and fire patterns. Yet the adaptive principles embedded in their traditional knowledge may prove more valuable than ever, not as static techniques to preserve, but as a methodology for responding to changing conditions. Some contemporary Yakut builders are already innovating, adapting traditional techniques to new climate realities, while maintaining the core principles of their architectural heritage. This ongoing evolution demonstrates that traditional knowledge isn't a museum artifact but a living practice capable of responding to new challenges. In this sense, the Balagan isn't just a structure but a process, a continuous negotiation between human needs and environmental conditions. For modern designers grappling with the imperative to create buildings that consume less energy while providing resilience against increasingly extreme conditions, the Yakut tradition offers valuable lessons, not as a romantic return to pre-industrial methods, but as evidence that the principles of harmony with place, material intelligence, and thermal efficiency can produce extraordinary results even under the most demanding circumstances. What ultimately makes the Yakut approach so powerful isn't just its technical sophistication but its epistemological stance, the way it generates and validates knowledge. Where modern building science proceeds through abstraction, standardization, and quantification, traditional Yakut knowledge develops through direct observation, intergenerational transmission, and embedded practice. Both approaches have strengths, but as we confront unprecedented environmental challenges, the complementary intelligence of traditional ecological knowledge offers perspectives that purely technical approaches might miss. The hidden lesson in the Yakut Balagan isn't just about staying warm without technology. It's about a fundamentally different relationship with our environment, one where human habitation enhances rather than depletes the surrounding ecosystem, one where buildings aren't static objects but participants in environmental processes, one where shelter doesn't stand against nature but emerges from a deep understanding of it. This may be the most uncomfortable revelation for modern sensibilities, that our technological prowess, for all its achievements, hasn't necessarily made us better at creating truly sustainable habitation. That societies we might have considered primitive actually achieved sophisticated environmental integration that our energy-intensive approach has yet to match. That true advancement might sometimes mean rediscovering what was known rather than inventing what's new. As the certainties of the industrial age give way to the complexities of climate adaptation, the Yakut Balagan stands not as a relic but as a harbinger, a demonstration that human ingenuity directed toward harmony rather than dominance can create remarkable resilience even in the harshest conditions imaginable. What we take from this explanation isn't nostalgia but possibility, the recognition that our capacity for adaptation runs deeper than we might have imagined, that solutions to seemingly insurmountable challenges might already exist within human experience, waiting to be recognized and reinterpreted for new conditions. The next time you consider what it means to create truly sustainable shelter, remember the Yakut people and their remarkable homes. Remember that at 72 degrees below zero, they discovered something profound, that survival isn't about overwhelming force but about profound understanding, that resilience comes not from isolation from our environment but from deeper integration with it, that the wisdom we need for the future might already exist in the past. If this exploration has shifted your understanding of what human adaptation can achieve, share it with others who might appreciate this perspective. Comment below with your thoughts on how traditional knowledge might inform our approach to contemporary challenges. The conversation about reimagining our relationship with the environments we inhabit has never been more urgent or more full of possibility.